We are looking at the problem new rating. So you can look at the problem statement. Let me just summarize it. So we are given an array uh, which has n elements a1, a2 till an, and every element denotes the performance of Kevin in ith contest, like AI. So there are n contests. AI denotes the performance of Kevin at ith contest. Let's say it has some rate. The Kevin has some rating X at that particular contest. So if he performs equal to his current rating, then his rating will be same. If his performance is better, then his rating will increase like by one. And if his performance is worse than his current rating, then it will decrease by one. What we can do in all in from this array of contests, we can choose to skip some contests L to R, like from L to R, including both of these, we can skip some of the contests, and we need to calculate what is the maximum possible rating that we can get, right? Okay, so let us say this is the contest array. Okay, okay, so let's say if like each of this element is in increasing order, right? So and also initially our rating was 0. So if all of this is in increasing order, then for every contest we'll get a plus 1 and we'll get a maximum rating of what n. But according to the problem statement, note that uh, note that Kevin has to skip at least one of the contests, right? So we will skip at least one of the contests, and the maximum possible rating that we can get is n minus 1. Okay, this is the maximum possible rating. So now what? And what is the minimum? Let's say all of this is, let's say we have just one contest, so we'll have to skip it, and so the minimum possible rating will be 0, right? So we can have these many possible ratings from 0 to n minus 1. Okay, so now this problems, so what we have done is we have made an array of our answers. Now we can binary search on our answers. So this problem can be easily solved using binary search on answers. How? Let's say we choose the element in between, let's say target. So what is this target? We need to see, can we make the answer greater than or equal to target? For example, can we achieve a rating greater than equals to target by skipping some of the contests? This is the binary search. If yes, then we'll search for these answer. If no, we'll search for this answer. Which means that okay, target cannot be achieved. Which means we need to lower our expectations of rating, and we need to go in the left direction, and otherwise we'll be going into the right direction. Okay, let us see. So, so I think till here it is very clear. So now comes the real thing. How can we check if we have a target? So how can we check if that can be achieved or not? This is the question, right? Okay, so uh, let us say we are standing at an index I. This contains some value a of I. Okay, and we have some rating x. All right, so now we need to see, is this rating possible at at this ith index? So we'll see. Okay, if we had this rating at some of the contest, right? Let's say we have x rating at some of the contest. So what we can do, we can just remove the all of the contests after this contest, and coming here we'll get this rating, right? This is the concept here. What we'll do, we will be storing the maximum possible rating from the start to the end, and then we'll check for every index, do we had the x rating in some previous contest. If yes, then we'll skip all the contests that will be after that, and now we get now that is how we can achieve the target rating. So if this is true, then okay, which means that target rating can be achieved. Otherwise, you'll need to go to the left half of the array. Let us see how can we achieve this via code. Let us first see our variables. So we have contests. We are taking in the contest, and then we'll take we are taking the ratings for each of the contests. Now we are creating a vector called maximum rating up to what contest? Maximum rating up to I, which means what was the maximum rating achieved till ith contest, right? This is the intuition that we just discussed, right? Okay, so now we need to fill up this array. We'll take the ratings and initialize the rating by 0. If current rating is less than the performance of the current contest, then our rating will increase, otherwise our rating will decrease, and we'll take the maximum rating achieved till that particular contest. And then we'll start our binary search. The leftmost, yeah, which means that the uh, lower edge of our answer array is 0, and the rightmost is contests minus 1, and the maximum achievable rating for now is 0, right? We'll start our answer by 0. Okay, now what? We'll continue the binary search while left is less than equals to right. And okay, and then I will take our mid, left plus right minus 2 by 2, which will get us the mid elements in the middle element in the middle of that array. And then we'll check if that rating can be achieved or not. If yes, then I'll be updating my answer to mid, and I'll updating the left and right according to the value written by this particular function. And let us see what this function is doing. So it function, yeah, this function is taking the target rating, and for for the target rating, we created a new variable called current rating, as we'll be updating this for every index, and we'll start traversal from back. So from contest, the last contest to the first contest, and here we'll see, okay, do we have any previous rating that we achieved which is greater than equal to the current rating? If that is true, which means we'll skip all of the contest after that particular contest, and then and that is how we'll be able to achieve this. So, and yeah, if we don't have this, then what? Then we'll update the current rating. How we'll update the current rating? If the current rating, if the rating of the contest, or what do I mean by rating of the contest? The performance of my performance in that contest is less than the current rating, right? Yeah. If my performance in the contest is less than the current rating, which means that my previous rating was greater, right? And in this contest, my rating got decreased. Otherwise, uh, that is why I'll update my rating for the previous index. So I'll add 1 to my rating for the previous index. And if my current rating, like the rating of the current contest, my achieved rating is greater than my previous rating, which means that current current rating I'll have to reduce 1, and my rating in the while during the previous contest was 1 less than the current rating. If we are not able to find any of such index, then we'll be returning false, and this is the solution for this problem. uh, I think I fumbled a bit while explaining, but you can look at this solution and it is very clear, very evident, right? Okay, yeah, see you in the next one.